Hello and welcome to the Unit 8 Section 1 video on identifying parent functions. So throughout this course we have looked at several different types of functions, and we've in fact spent about an entire unit on every single function. In the case of quadratics we actually spent 2 units on that. So now we're going to bring everything together in what I call the Great Nine, and that is 9 different function types, all of which we have covered in this course. So, talking about the Great Nine, they are all parent functions of a family. Okay, so we have constant functions, as you see here in this top row. You have the constant function, linear function, absolute value function. Those are all parent functions to a bigger family, and those families of functions can be created using transformations of the parent function. And we've talked about transformations at length in this course. So every linear function has a family of functions. That linear parent function, you add a number to x, or if you subtract a number from x, or if you multiply x by some number, those all give us transformations of that parent function. Same thing with absolute value and all the others that we have covered. So let's talk about all 9 of these, and let's talk about them all in one place. So we have the constant function and the linear function. The constant function we covered briefly in Unit 0. The linear function we covered back in Unit 1 when we did arithmetic sequences and we did linear programming. Absolute value function came in at the end of Unit 1 because it's essentially 2 different linear functions, and we're going to talk about the fact that it's 2 different linear functions coming up here in a couple of sections. Now, as we moved on into Units 2 and 3, we talked about quadratics, and then in Unit 4 we started to go to higher order polynomials, which included the cubic function. And then in Unit 6, we covered radical functions, including your square root function and your cube root function. And then in Unit 5, we did rational functions, where the variable is in the denominator, or is in the bottom of a fraction. And then in Unit 7, we did exponential functions, where you have some base and the variable x is in the exponent. So that's just a quick wrap-up of all 9 function types that we have covered in this course. Now that we have covered all of those function types, let's see if we can do a little bit of identification. And we want to do it by 3 different methods. We want to do it first by identifying by graphs, and then we'll briefly talk about what to do with tables, and then we'll wrap up with what you have with equations, which should be fairly familiar to you at this point. So let's start off by identifying by graphs. All you have to do is see what kind of shape it has. And it may be a stretched version, a compressed version, reflected or translated, but mainly we want to see, does it have the shape of one of those 9 parent functions that you had on the previous page. So for example 1, part A, this has the shape of a quadratic because it is a parabola. So therefore, this is a quadratic. For B, we have what looks like an absolute value because it comes to a V. It's in a V shape. So this would be absolute value. Then we come along to C. C would be a rational function because remember, rational functions have asymptotes. They have often vertical and horizontal asymptotes. Because remember, whatever value of x is in the bottom that makes the bottom 0 cannot be used, and that's typically where we have an asymptote, but not always, because remember, if we cancel the same thing off the top and the bottom, then we have a hole. So just a little bit of recap of what we did with rationals. Then for D, this looks cubic, and your first thought may be to cubic, but remember, we also have the cube root function, and remember, that's an inverse function of cubic. So it looks like a cubic function, but turned on its side. So therefore, we have the inverse function, and this is a cube root function. For E, we have a straight line, which may make you think linear, but it's actually a special case of linear because Every x value has the same y value. This is a constant function. Then for f, we have a function that ends at a point or begins at a point. So that is a dead giveaway. That is a square root function. And then we've got a couple more examples on the top page here, top of the last page of this section. So for g, it looks kind of like the square root function did, but it goes infinitely in both directions, and you'll notice that it starts to approach a value here, that being -5 on this graph. So this would be an exponential function. And more specifically, this would be an exponential decay because it is decreasing and then we start to level out. And then for h, we have a good old linear function. Now, when presented with a table of values, you can graph the x and y coordinates to determine the function type using the graph shape. So what we just did, you can use for a table of values, but you'll have to plot those data points first and then determine the function shape. A couple of notes on that. Consider two data points, 0, 0, and 1, 1. Okay, those are both coordinate pairs. If you plot them on a coordinate plane, you might very well think that they are part of a linear function. In fact, they actually belong to each of the parent functions that you see here. The points 0, 0, and 1, 1 can be on a linear function, they could be on a quadratic, they could be on a cubic, or they could be on a square root. All four of these contain those two specific points. So therefore, you have to have a sufficient amount of data to be able to determine what type of function shape that data generally follows. Additionally, remember that any parent function you use to approximate a set of data should never be considered exact. However, these function approximations are often useful for estimating unknown values. So we've already seen in the previous units you can easily determine the type of function when presented with an equation. So we're going to just take a look at a few of these equations and see if we can figure out what they are. So for a, we have an x to the first power, so that gives us that it's linear because that x is not in a denominator, it's not under a radical, it's not x to some other power other than 1, so this is linear with a slope of 1/4 and a y-intercept of -3. Then we get on to b. This one has a fraction as well, but this time the variable is in the denominator, which makes this a rational function. For c, our highest power is 2. It's in standard form. It's a quadratic. For d, our variable x is in the exponent, which means it is exponential. For e, we have a radical, and the variable is inside the radical. So therefore we have a radical function, and more specifically, a square root function if we're going off of the Great 9 off the front page. And then finally, this is an absolute value function. The dead giveaway is the absolute value symbols. And the variable is within those absolute value symbols. So this is just a brief recap of the functions that we have covered here in this Algebra 2 course. As we move on through the rest of Unit 8, we're going to take care of a few more odd and end topics to kind of close out this course. The next one being function operations. Now that we know all these function types, we need to know how to operate these functions together. So that's going to be in the next section.